Hey, welcome to Coffee Compiler Club. I don't know what we're going to talk about today. I'm sure we'll think of something. And compilers and language runtimes and typing systems and whether or not you should start a consulting business. Recorded, show up on YouTube. That's it. Spiel. What do I got here? I have the only opening thing I have is I talked about cyclic types last week under the theory that I wasn't quite certain if this was an issue and was I doing a stupid and heading down this path. And a bunch of people lit up both during and afterwards and on YouTube comments saying it's a known big issue that every far enough advanced programming language runs into, and everyone has different things and their PhDs to solve this thing, and no one's got a great answer. So I was encouraged to just, carry on. And so I spent the last 2 weeks really trying to get the same cyclic types, a subset or a simpler version of the cyclic types I have in AA, moved over to simple. I was trying to not take the most complicated parts and clean up as I went and all that. And now I think I have cyclic types running in simple. And I can finally put method calls in where inside of a structure definition, you have a function who takes that struct, and that's your cycle right there. And that was what I stopped and hit uh, and took my time to go clean out. So I have some functioning thing that does cyclic types. And I can talk about why it's a bitch.
Yeah. So in this case, the sort of challenges you face were they more for things like like code generation, determining the size of types, or things like, oh, how do you type check cyclic types?
No, well, it becomes how to type check in the end, but that's not what it is. It starts with I'm building up types with essentially a syntactic grammar for type elements, and there's a recursive descent implementation that just says I see an int, well, it's a base type, and you're done. I see a struct that has fields. Fields might be ints or floats or whatever, and that's recursive descent. In the absence of cycles, recursive descent works great. In addition, in the absence of cycles again, I can hash cons all my types. I've done so in C2, was shocked at how high the hit rate was. I've repeated that since, and the hit rate's 99.9%. It's something ludicrously high. So hash consing means that I can sort of very cheaply create a type, hash cons to install it, and now I have the one unique instance of that type variable that everyone uses thereafter. And type equivalence is not a recursive descent walk. Are these two types the same? It's pointer equivalent. So it's a one clock cycle after interning. So that's where I started from prior to cyclic types. It's easy to describe, it's easy to implement, it's easy to see it's correct. Everyone understands it. The type checking comes because after grammar analysis and building IR, I simply run the optimizer until the types stabilize. And if anything hits a type error, which would be mixing types, so it's a complete lattice. So if you mix two junk types together, you mix in a float, mix it and float together, you go to a bottom. That's an error. So if you ever find any errors left over after the optimizer's done, you have an obvious error. And then there's some pointer back to where it came from, and you can blow up on them and say, yes, here you mixed int and float, or you mixed int and pointer, pointer and float, whatever. You mix stupid things, can't do it. You got two structs, they have different fields. They don't, this struct has an X and this struct has a Q. They don't match. You blow up, go to bottom, type error. Okay, great. So now I have type errors and I have typing done as part of the core. Just go run the optimizer through. Um, that's been up to chapter 22 in simple. So a lot of code runs that way. It's all great. This is basically what C2 does. Although they get a type error there, I generally explode and complain to the verifier folks that they let something slip by. And yes, we found a few bugs in Hotspot that way. Um, so then I get to cyclic types. And now I want to intern a cycle. And how do you intern a cycle? And how do you compare if you have a new cycle you just made and you have an interned one, are they the same? Well, now I'm comparing two cyclic structures for equivalence. And that's actually an obnoxiously tough problem. Um, because the edges are labeled, it's not the NP complete version of general compare, but any sort of recursive descent solution is just wrong. So the obvious Java implementation that says call dot equals, which then recursively calls dot equals, went from exponential when you were just sharing to Stack Overflow and death. It's just wrong. So you have to have cycle-aware equivalence checks and cycle-aware hashes because you can't build these things incrementally, which you've been doing all along, and hash them incrementally. You have to hash the cycle all at once. Um, there's just a lot of engineering crud to get it alive and working well and not endlessly allocating and throwing away. Like the interning actually works. Um, At the end, though, I now can say I have some cyclic mass of crappy thing and I have a new one and I can compare them and say they're equivalent. And each of their subparts will be equivalent or not. And I'll clean up all the matching subparts and the new pieces of the new guy. All his matching prior interns got matched, but his new cycle showed up and it all works. And it's a lattice still, so I still get the nice properties out of the complete bounded ranked lattice thing I have, semi-distributive, blah, 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 which means the optimizer runs in linear time to a fixed point, and then you look for bottoms. And if you don't see any bottom types, they're good. So the real bitch was engineering the interning of the cycles. That was what took 2 weeks of screwing around on try number two. I spent a lot longer on AA when I didn't realize that I couldn't do most of the things that you thought you could when you were just doing structurally recursive descent.
So how
So
do you end up doing the cyclic?
say again,
The, how do you end up doing the cyclic
cyclic
interning?
compare.
Yeah.
Yeah, you have to have a visit bit. Um, and the visit bit says, I have compared these two things before. So I come to two things and I basically build a pair. And the pair is really done as a, oh, here's Mark Falco.
Mm. Yeah.
The pair is
Yeah.
basically done as a every type picks up a unique ID. Because I'm interning, I actually don't get very many of them. You get a few
Hmm.
hundred at
Oh,
most.
okay. You get the compare the how about the hashing?
Um, yeah, so the hashing has to run same. He has to decide he's closed. So what I did with the hashing is I gave up some perfect great hashing and
Hmm.
I stop all cycles during hashing. Now the equivalence guy has to round all cycles out. But the hashing guy can stop and say, I'm going to recursive descent until I hit a particular kind of type, which it will show up in every cycle. So in my case, it's a struct. You have a pointer to a struct, which is a field, which might contain a pointer. So that's your minimum cycle.
Mhm.
Um, if you have to have a struct somewhere in the cycle. The struct stops and gives you back a hash, which is based on things he knows about right away, like his set of field names and some things about the fields that are known right away, but not the type of the field. So he's not taking the field's hash.
Yeah.
He's taking the name of the field and the
Yeah.
order of the
I
fields and
think
shit
we,
like
we
that.
we glossed over that on the last discussion. Only
Say it again.
know about. I think we glossed over the on the previous Friday CCC about that. Only show the names, only use the names, not
Yeah, right.
the.
Yeah, we had some discussion there. Right.
Yeah. Yeah.
So I ended the hash cycle
Mm.
at structs, and so pointer to a struct gets the struct's hash, which the struct hash doesn't have to go any further. So the recursion
Yeah.
stops on hash. There's no
Mm.
cycles in the hash.
Yeah.
Um, because of how AA types work, and they're all anonymous, he actually does a true cyclic hash, and it's a more difficult thing.
Mm.
Um, I just make the hashes not look at the types in the field types, which means that you get a lot of hash collisions on structs. So you have the same name struct, And there's a bunch of variations where sometimes the fields are known to be int, and sometimes they're known to be somebody's age, 37, and sometimes it's known as name is Cliff or whatever. You don't get to use the precision of the
Mm.
types where you picked up constants there.
So they're all lumped together in one cyclic type. So
They're all lumped
they're
together in the same hash,
in the
which
same hash,
means,
yes.
right, in the hash table, they're in the same bucket.
Mm.
And you have to walk them all to see which one is which. So we can argue about asymptotic performance there. Um, but the equivalence guy has to have a visit bit and run the cycle comparing da 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 two by two until he loops and then he says, I've compared you two before. I'm
Mm.
going to assume that you're equal
But
and not bother to recurse,
how
cycles.
about then a special versions of a cyclic type? So in order to track that more precisely.
That's what AA does. That's what I said. That one requires the smarts from the cyclic hash. That one,
Mm.
because of other things that go on in AA, like anonymous structs everywhere, I actually have to use the full Aho, Sethi Ullman, DFA minimization. DFA
Mm.
minimization.
Mm.
You have two cyclic structures with named edges,
Mhm.
and there's a proof that you can't do it without running something, can't do it in linear time, and then Sethi Ullman is in login, and it's a slight modification of Sethi Ullman's DFA minimization.
Mm.
But that's a kind of a heavyweight thing to do when you're interning types. So AA
Yeah.
also recognizes when he has no cycles, which is very, very common, and then just recursive descent. It's very easy. When you
But for
have a
the
cycle,
key,
he recognizes it though and says, okay, I got two cyclic types. Let me go flip to the other algorithm. And there's a second algorithm that does the
mm,
DFA minimization.
for the case for the simple, in order to hash to stay stable, we just only use the field names or their types for equivalence.
Yeah. Yeah.
Mm.
Yeah. Otherwise, right. Otherwise, you have to keep cycling and then you have to
Mm.
stop the hash, which means you have to stop and say, this hash is built from the cyclic pieces plus, and so it has to match somebody else's cycle of the same set of pieces.
Mm.
Plus, they have some deltas, which would
Mm.
be the cycle plus I pointed off to a field which has an int, and the int has no further types behind it. And this int was known to be a U8, and that int was known to be a 17 or whatever. And so I can tell
Mm.
they hash differently, and that would make life faster or something.
Mhm.
How do you do the
So
cycle detection efficiently?
yeah, exactly. It's not something. Yeah, I'm not actually doing cycle detection. Well, okay, so you missed some of the lead in here. In I added cyclic types to simple. I've had them in AA. The simple version is simpler on purpose. I'm dropping some features that AA has. Um, then it turns out that I don't need to run an official cycle detection algorithm in these simple codes, but I do have to have a visit bit that says I've been here before, and everybody gets a
So
visit
what
bit.
about what about multi-threading, or does simple not have that?
No, no, this is for the typing analysis for simple.
Oh, gotcha.
So this is in
Okay,
the core compiler with cyclic types. So
I
no
see.
multi-threading. There is a whole other game if you're a GraphDB and you have edges and nodes and you're trying to do something with can I do a query and I'm editing and the query looks for cycles that I don't know. There's a different thing there. I don't even know if those guys would do that thing. And swallow a whole cycle as part of a GraphDB query and also be correct in the face of mutation. I don't know. Fine. Different problem. I have cyclic types. I can now write methods. That was what that one was about.
Yeah, no, cyclic types indeed are they were a challenge for my compiler as well. In that with the type checker, for example, because I have it's not quite Hindley-Milner, but like bidirectional type inference, I think it's usually referred to where you create an array, you push into it 10 lines down, then it knows like, oh, the type is X. But I mean, technically, you can do things like, oh, push the array into itself or things like that.
Right.
Uh, and that at the time also blew up things like type checking, but also type formatting. So for
Yeah.
type checking, I think what I ended up doing is unformatting cell one. I have a depth limit. I think I
Oh,
just arbitrarily set it to 64. The idea being if you have a type that is more than 64 levels deep, I think you have bigger problems. Like we're talking
I
about like
threw I
uh,
threw the bit check in on the thing here. Sorry, carry on. Let me see if I pull up like this is like a code thing.
so the thing there is for this cycles with checking formatting that specifically handles um, the exacting type. So in the sense that if you were to imagine each type has a unique identifier, like from 0 to whatever, it handles cases where you have, say, a type with identifier 4 storing a type with identifier 4. So essentially what it does, it has a depth, and then for type checking, I believe I maintain a set essentially of which IDs I've seen. And then if somewhere in the deep end it finds a recursion point, it basically says, oh, we'll treat it as compatible because
Hmm.
then as it starts to unwind, then it will end up performing the actual check at some point. And if at that point it's incompatible, it will still say that. So basically, there's a bunch of places where it says, are we too deep in the call stack? Do this thing.
Hmm.
Uh, One area where I don't handle this specifically is I have a mechanism kind of similar to hash consing where in my compiler, if I have different instances of the same generic type, so I have two functions. One has like array of int, and the other one also has array of int somewhere in like a variable or whatever. The structures for both those type references are different. Like they both refer to the same base type, like array,
Hmm.
but they also essentially have a hash map of the type arguments.
Hmm.
And those are structurally the same, but normally they're different because they use IDs. Like
Yeah.
these type argument hash maps are stored in some array somewhere and they're referred to by an index.
Yeah.
And so we end up with is basically two data structures where they, yes, semantically they refer to the same type, but they have different indexes.
Hmm.
And so
That.
there's this process where it interns those or hash conses,
Oh,
whatever you call it,
yeah.
where it tries to converge those onto the same thing.
Yeah.
That's where I don't have explicit handling because, as far as I remember, famous last words, it isn't necessary for my setup. Because if I have a type that is cyclic, as in you store an array in itself, like
Yes.
array.push array, for example,
Yeah.
then the type checker will already throw an error. It'll say like, hey, I can't infer this thing because it's cyclic.
Oh,
So
I see.
what the hell?
Right. I can now infer it.
Right.
New
And
with
then
this cyclic types I can now infer.
right.
Well, not infer.
Uh,
I'm sorry. I can now represent that type. I can't actually infer it.
right. So in my case, it will say, infer error. And then when it prints the type
Mm.
uh, as part of the error message,
Yeah.
that's where it has a depth. And it will just say, oh, if the depth is greater than 64, we just print dot 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 and we bail out.
Right.
So the
So what I
type in
was
the
trying to show
error,
here is I just use a bit set, the visit bit set
right.
that just stops the cycle and uses a short form. There's a long I'm going deep and then the short form, which is in the case of like a struct with fields, it just says the struct name.
Right, right. So essentially I do something similar. So you can end up with like a type error, like, oh, the type array brackets, array brackets, array brackets,
Right.
etc. Dot 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 can't
Yeah.
be inferred.
Right. And I would cap that and just stop it at the one and say, it's here. And it's
Yeah,
like,
I have it for 60.
you have
So
a
because
60. Yeah.
when it recurses, it doesn't, at least for formatting, it doesn't check, hey, did we already format this type? It just says, are we too deep? Bail out.
No, I get it. So you're carrying a count along instead of a visit bit.
Yeah, basically.
Yeah. In AA, I went a step further and said, when I see a cycle, I go ahead and give it a unique name, which would be a type variable name. And then in the printout, you would get these type variables to show where the cycles came. But that means that every
Hmm.
printer takes two passes. He passes once looking for all the cycles and all the sharing points, including cycles. He comes up with names for all the sharing points, A, B, C, D, whatever type variables you're using, and then he prints using those. And it's very nice for understanding cyclic type printing, but kind of a pain in the butt to do printing. The A one, I just said every struct, which is my cycle point, has a name. Therefore, I'll just give you that struct name so that that top line, which says if the visit bit triggers, return the print of str. That's the short form. And for structs, that's just the struct's name. Cat, dog, animal, Cameron's favorite names.
Yeah, no, and that perfectly fine. And then for the uh and then finally for like memory layouts, I do the same what basically everybody else does. If you have something that's on the stack, it cannot be recursive into itself because you cannot calculate the size of a recursive thing that exists on the stack. But yeah,
Oh,
it's
the size. No, I can
so
get
if you have like
sizes.
a structure that's stack allocated and it stores an instance of itself, like because of that recursion, you don't know how much space to reserve on the stack. So that's where the type checker will say like, oh, you can't do that.
Hmm. Okay, yeah, I
Um,
don't let you put a struct in a struct. You can have a pointer to a struct in a struct.
right.
So you
No,
could
it's the
put
same.
pointer on the stack. So I could have a struct that was stack allocated who has a member field, which is a pointer to like a linked list entry.
Yeah, no, that's fine. So the way I did it, for example, the option type is stack allocated, for example.
Yeah,
Um, and it's maybe not the best example because it has a case where it sort of terminates like the none value.
yeah.
But let's say you have a user struct that's stack allocated, and its first field is friend, and it's also a user struct that's stack allocated. The type check would say, hey, that's a recursive type. We can't do that. However, if it's a pointer to a user struct, that's totally fine because
Okay,
this like it terminates the recursion basically.
right. Oh, but you want to print the what it pointed to. One user struct points to another, right?
No, so the way like for the size
Oh, for the
calculation,
size calc. Oh, yeah, 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 yeah.
like pointers are basically terminals as far
Right,
as
yes,
recursion
right,
goes.
right. I have something very similar. I go ask what your log size is or whatever, your power of two scale size. And he
Yeah.
says pointers are 4 or 8, whatever your pointer size is. Yeah. Yeah, this is the recursion version of print for structs, which if you're the short form, it's just your name, although there's a debugging hint. You shouldn't ever be free when that print happens. So that's just a debugging hint. But then there's print your name, and then there's some other shortcuts for if you're an array struct, then you do other things, and otherwise you print curlies and you print your fields recursively. Um, and there's a bunch because it's the debug print. It includes a lot of handling for broken cases like I have a field. The field does not have a type. Because it doesn't have a type, I don't have to recurse, but I need to not crash in the debug print. So the debug print will handle broken cases left and right. Um, yeah, yeah. So full of cyclic things. Here we go. You asked Theodore. So here is the equals call and the recursive, the cyclic equals. So equals is what I do if Java equals was used in a hash table, for instance. And I already checked that you're two compatible types. So you're in the second half here. I know that the type that got passed in has to be type struct. And then I'm going to do some static parts, which is their names are equals and some flags are equal and the count of fields is equal and so on. And then I just structural recursion. Walk the fields, they have to be equal. This is normal structural recursion, just fine. The visit flag is when I've started some sort of cyclic operation and he immediately changes his behavior in a bunch of ways. I don't build any more types, and I don't intern types I build. I build types without interning. I'll collect the entire news cycle without interning any of them. And there'll be some mini parallel cycles I need to go compare on. I'll call the cycle equals guy, who just says call cycle equals, except he needs an extra status bit that he knows is available. So that's it. Assert it's empty and clear when you're done. And then the cycle equal guy comes through and says, do all the other things the other guy was doing, your statically equals or fields are the same or whatever, then make a pair ID. I'm comparing two guys. Are they cyclically equal? Make a pair ID. And because my UIDs are small, I get two of them together. And maybe someday it has to be a long instead of an int, but fine. And then I look you up. And if I got a hit, you're true. And if I don't, you go on the list. And then you do cycle equals. So that stops your cycle because you find the pair right there. And the sort of moral takeaway is every basic thing I do with types gets a cyclic touch. So there's hash gets touched and equals gets touched, adds a cycle equals, and print gets touched, it has recursion support. Um, the constructors all end up getting touched as a consequence of that. And then because I don't intern immediately, I have two variations where I either make you and intern you, which is the normal one, or I make you and don't intern, and I collect a bunch of these. And then suddenly I say, okay, intern the whole cycle as a unit. And so just a butt ton of engineering and new code. And that's what I spent the last 2 weeks on. And I'm kind of rounding down the last little odds and ends. So I can do meets and joins and have a lattice. But I have a couple other operations I do. One of them, you like make this type read only. You lost mutability. You threw away mutability. You constructed it as a big cyclic thing, and you're done. And you want to hand it out to somebody else, but you don't want him to modify it. So you want to hand him a read-only copy. So you need to make the same type, which has a cycle, except you've gone to all the fields and marked them read-only. So you get a news type, which is a cyclic type with the fields all marked read-only. And there's another version of that called greatest lower bound, where the cycle remains the same, but the edge is out. The leaves that leave the cycle have all had their fields produced, knocked down to the greatest lower bound, which is what you get out of type inference. If I don't know, I built something and I just said it's a value or var, whatever, I'm doing type inference on it. And then somebody wants to add it, edit, and change it, hack it. What are the rules? What are the limits? Well, the limits are whatever greatest lower bound says that you get by default, which means if you assigned a 3 into it and later you assign a 17, well, maybe it's a byte. And later you assign, 5 billion. Okay, now you're a long. So that's what greatest lower bound lets you do. So all those are now coming in. I think I have one more hit on greatest lower bound, and then I think that's all done, and all my tests will pass. And then I could go actually make cyclic types for real, which will be, like I said, will be method calls. And then out of method calls, I'll finally get a string where I can do method calls on the string.
Nice.
That's what I'm really looking for. It's like, geez, takes forever to get there. Fine.
Cool.
All right. We have to change topics.
So that will probably conclude chapter 23.
Yeah, I'm on chapter 23. Yeah, well, there's a documentation thing now. This will be chapter 23. I'll have to rewrite whatever the README says and say, today we redid most of the type system. And we went to cyclic types. Here's why, and then here's the implementation. Here's the engineering design decisions around how you build cyclic types, and what you do with them.
And how did you go to a great lengths in order to support that in one pass?
Yeah, I'm trying to think if that's the case. That's a valid question. Like, should I have made a separate typing pass per se, right? So there's a thing that I go back and forth on this a fair amount is a easier answer is to say the types all bottom out as there's a type def and a type ref as two different things. And the def you look at my hash table, the type name, it maps to your def. And then a ref is basically the string that you're going to look up in the hash table. And all your cycles are broken by this ref lookup, where you're walking through the types, all recursive percent, it's all quick and easy. And at the bottom, you say, oh, I got a pointer to a person object again. But I don't have a struct for person object there. I have the string person, and I look at the hash table, and that closes the cycle.
Mhm.
Under that model, life's a lot easier. Your cycles are all broken for free, so you can do recursive descent. That's great. Um, but you can't represent other things about how persons are other than the base person because you only have the one instance of the person. It's the one you found in the type in the lookup when you the hash lookup to go back. That means there's one flavor of person object in the world, and I can't have a localized person object that hasn't escaped, is completely done locally, and retain type info about it. Now, because it's retained locally, maybe escape analysis does all work. Local optimizations on it, like loads and stores against a freshly created person object, can optimize fine. That's great. But if I build a person object that has something special about it, like these are all persons who are employees of a company or whatever,
Mhm.
that set of things can't be represented from other person objects because the collection of them isn't a local thing. I got persons from all over. They're all employees of Oracle.
Mhm.
And then I hand this off to the Oracle admin code that's going to go compute vacation hour tax, blah, blah, blah. He can't start by saying, it's all Oracle people. And I know that. So I don't have to do whatever. I have to call the generic, go look up how I compute vacation hours for this company.
Mhm.
So if I want to have variations of peoples that I know something typically about, I have to say, when I point to a person, it's the unique person in the type system that has the uniquely well-known values that say something stronger than the employee is generically some company, whatever the employer is some generic company. Here I know it's Oracle, and there I know it's Sun or whatever. So it's a stronger analysis.
Mhm.
And then at expense of like making this obnoxiously complicated engineering hack to go for fast, efficient, easy cycles. There is a dumb, bad version that would have been a lot easier to implement. Um, I went for, fast and whatever.
Yeah.
Now, will I make any progress with optimizations with it? Oh.
Mm. Yes.
C2 kind of gave up at that point as well. Um, Not quite. Java gave me some hints so I could close some cycles, and I did so. But I don't recall if I guess it totally did. Now that think about it. I had a cycle check in C2. And I know I could build them, but you got handed to them because the Java type system had already closed. So Java C had already closed the cycle, if you want to say that. And then
It
you put it in the
wouldn't
bytecode.
pass. Yeah, it wouldn't pass if it's an infinite, if it encounters an infinite cycle type that cannot compute, cannot type check.
Yeah. I'm
So
thinking, who did the original cycle check? Well, Java C did.
Java C, of course.
And he
Yeah.
didn't do any optimization.
Yeah. So C2 is a matter of fact how many will have to discover where the cycle ends, so we can know it. That's a thing.
Right. And I'm pretty sure I would build cyclic structures. Given a cycle, I would build a cycle, but I didn't do the fancy intern hacks that I was doing now. So I had something else going on. I think I was only allowing trivial cycles of some kind. I bailed out past that. When I say bailed out, I approximated pretty harshly
Hmm.
because that was also it was 25 years ago. It was like a kind of for me at least, it was a brand new problem. I'd not seen this before, and
Could
it's like,
you
oh,
have an advanced or anything other than a trivial cycle in Java? We're just talking straight inheritance, right?
um, yeah. So in the actual type description, yes, but when C2 sees things, he gets like unrolled. Like suppose I build a linked list whose payloads are things like ABC strings, but they link one to the next. So if I have a linked list type in exactly one instance of it in the universe, and I say, oh, I have a linked list whose payload is some string thing, then it's always string bottom. And if I make a bunch of linked lists, bang, 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 and then I want to peel them off in reverse order, the local guy can say, while the linked list type tells me his type is string, I can see I've just stored a C into the last guy. So I can unwind the C and say, oh, I mean, unwind the last store and say, okay, the payload is C. And then I can say, follow the next pointer, which I have locally, and now gives me this other object who I can reverse. So I can unwind locally A, B, C. I make a new A and then say B points to A and C points to B, and I made a linked list. Then I can say, pull the next, pull the head off the next, and the next, and the next, I get CBA. Okay. If I build this ABC thing, and then I pass it to somebody else who doesn't have local information, I can't describe it's a linked list of A, point to B, point to C. I can only say it's a linked list. I can't tell you its depth. I can't tell you that the next field is always null or always not. It's mixed. In this case, it's mixed. There's 3 not nulls and 1 null to end the list. And the strings are any string. So I don't have any sharper description. So you can imagine a scenario where I want to say, I have linked lists that are unrolled in the type system where I know something about them being ABC as a full unrolling. There's another version of more approximate where I say, I have a linked list. Maybe I don't know its length, but I know it only contains A or B or C as strings. And maybe I can say something like, oh, the strings are all length 1, or it's ints, 1, 2, 3, and the range is numbers 1 to 3 or whatever. I can get a more precise type, which then turns into more optimization later when I've handed you a linked list of enums and the enums come in a narrow range. And then I go to a switch statement and say, pull this thing off the linked list, grab the enum, switch on the enum, do something. Well, what are the limits of the enum values? Oh, it looks like there's just the first 3 enums out of the days of the week. I can skip the other 4 days and not optimize, not do anything with them or whatever. So there's definitely optimization opportunities if you can hold on to partial information. And I know C2 did some of that, and I'm trying to remember what I would have done in the case where I know I would hit cycles. I had a cycle handler that stopped and, like I said, brutally approximated, um, which probably meant that I was limited to one linked list object, but he didn't have to be the default payload of whatever generic type. It would have been in this piece of the code where you're constructing linked lists, I would have picked up, I think,
So
picked up.
maybe that's the solution. Just approximate. Oh.
Yeah, yeah. And honestly, I'm mostly doing that with the simple code right now.
Mm.
So if you have cyclic types in the definitions, you get the very generic version of things. You say, give me a new linked list. You get a version where I know the payload is 0, null, it hasn't been set yet. Then you set the payload. You get a version that has the sharper payload over here, and over here is the generic one. Then in this code where you said, make me another new linked list, and you build up, I'll build you up a payload that is made from the meat of the different elements. So the usual story here is I have a loop and I say for I equals 1 to 10, linked list of blah, 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 pick up payloads. I can say something about the payloads. And I think C2 is able to do that too. I'm not positive, but I think so. So there's a chance to do something useful with it. And having paid this price, I think I don't have to deal with it again, if that makes sense. The type system is it's its own little thing. It's its own little rules, and it's very closed-minded. There's a very sharp, narrow interface to the type system. So once the types internally seem to be correct, they pass all tests, they form a lattice, the lattice is heavily tested for, then I can walk away from it and say, forevermore, in theory, forevermore, I can just have cyclic types and not worry about it. That's my theory, and I'm sticking to it.
Yeah.
Hey, Arthur. It's
Hello.
round 2 of cyclic types and how they're used to optimize code or not or whatever. And
Sounds fun.
Yeah. C2 messed with them back in the day, but didn't go super far down the path. And it does.
Wait, why would you need this for, like, when does it show up on Java code?
I just have a linked list. It's got a next field, a linked list. Oh, I got a cycle right there.
Inference. So it's not in Java code per se. It's in C2's inference.
It's in C2's.
Okay.
It
What
lets
what did you
me.
do with
Sorry, go ahead.
so how did you use this?
Yeah. We were just like literally seconds ago talking about how to use this. It means that
Ah,
if I
yeah,
have
got it.
some section of code, there's a generic linked list which says I have a payload object, which is object whatever. It's some payload, I don't know. And all generics have been wiped free, type erased, they're gone. I have some piece of code over here where I say make a new linked list, shove a cliff into the payload. Make a new linked list, shove an Arthur into the payload. Make a new linked list, shove a Cameron into the payload. So if I take this set alone and it's run in a loop and I'm doing meets as I go, I'll end up with a linked list which has a payload field known to be string, not object. And the linked list header, the linked list next field, I'm not counting that it went three deep. It has some, it's linked list or null. But the linked list or null as a type in the type system for all optimization and analysis, not type checking per se, says it's not a linked list with an object, it's a linked list with a string. With some count of linked lists, so it's a linked list or null pointer to the next linked list, who knows, and a string object. And then, for optimizations follow after that. I take this thing, hand it off to somebody else who says, oh, it's a linked list of strings. I can quit my instance of casts that, you get because you got generics get unwound. Everyone has instance of checks at runtime. You can get rid of it.
Did you model this in C2?
Yeah. At some limit. So I'm trying to remember 25 years ago, I definitely saw cyclic types in C2. I put handling in. It wasn't perfect. It bailed out sort of aggressively to avoid getting issues with, infinite recursion or stack overflows or whatever. But I definitely could see cyclic types, and I'm pretty certain I would sharpen in the scenario I just mentioned to a string payload from an object payload.
So for optimization purposes, the point is to undo type erasure in a sense.
In C2's case, yes, it was undoing type erasure. Yeah.
In simple, do you need to do that, or wouldn't it be simpler not to have type erasure in the first place?
I don't have generics yet, so it's not an issue. I don't have any type erasure.
Right.
I'm trying.
So,
The simple version of this is just so I have a canonical same way to represent all the types that flow around the system. So the piece that you missed, Arthur, was of the various ways you can implement cyclic types, and every compiler fights this at some point. A way is to say the linked list header has a next, which is a pointer to a struct, which is a linked list. It's called a linked list. So I have a type def, which is a linked list full definition, and a type ref, which is just a string that says linked list. And I have a hash table, and my cycle is broken because I say, oh, I have a pointer to a type ref whose string is linked list. Look up in the hash table, go back to the def. Now I have a closed cycle with the hash table lookup in the middle to break the cycle. But I have the def only as the only instance of linked list types in the world, and it has the canonical basic definition of an object payload. And that under that model, if I go through a loop where I say make a new linked list, shove the payload as a string, make another one, shove a string, shove a string, shove a string, and then take this string only linked list, hand it off to somebody else. At the time that I build this, he's always saying linked list points back to the generic definition whose payload is object, even though I put a string in over here. I don't have a version that I built off to the side where I can raise the type value to being strings for just this piece of payload, because I don't have a representation that says I have a pointer, I have a linked list, which has a next field, which is a pointer to a linked list ref, which looks up over here in the object, in the payload is object. I want to have a linked list as look up to, it's this guy, not the one over here, it's this guy, and it's string, and I have only strings in this particular linked list. So that two cycles, one cycle where I have object and one cycle where I have string in the payload, is two separate cycles. And that's what I added to simple, because this lets me, it's more optimization down the road, and it's also, it removes issues I had right away where I was just trying to deal with cyclic types, and I had to make a decision on how to deal. In my case, I was looking for methods. I built a struct. It's got a person object. Within the person object, it's got some sort of lookup table for tax computation, which is a function of the method call who takes a person object as this pointer. When I have a cycle, I have a person object has a field that is the tax computation, which has a person object coming in as an argument to the type. And so therefore the type of a person object has a function pointer as a field, and the function pointer has a person object, and you get a cycle just right away. So I hit that and said, okay, let me just add cycles now and get it out of my face. And I went to I'm going to go ahead and do the full-blown cycle thing with at least some level of optimization possible. Not the one where you do a type ref to a type def and lost all person objects look the same. And that was what I was bitching and moaning about for the last 2 hours, last 1 hour.
So I'm trying to see Java because Java still has methods, but it doesn't parse it and build the CF routes.
Yeah,
He hands you the bytecode already resolved.
You have to work out the difference here between there's multiple passes in Java, including Java C. Java C found the cycle in the first place.
Yeah.
Not Java, not JVM, not C2. Java C found the cycle. And he encoded the cycle in the types, in the bytecodes. C2 unwinds and gets handed the cycle in his face. Here you go, your cycle right here. He doesn't have to do anything to find cycles.
Most likely because it's not single pass, the Java C.
Yeah. Oh yeah, Java C is definitely not single pass. So the single pass thing is sort of like a red herring here. You have to deal with this issue one way or another.
But if you can delay, if you find the cycle, you just wait to close it. But here we want just as soon as we see to generate something. And
I have to close the cycle at some point. Yeah. Closing the cycle means I have to decide how I'm going to represent cycles. One of them is the def ref split.
That is the difference. So Java can just wait to the end of the class definition to close the cycle.
Yeah.
But we want to generate here right now, as soon as parser hit that. And we have to generate something that we can later represent the whole cycle. It can later turn into the whole cycle.
Yeah, but I'm claiming that it's still a red herring in the sense that the act of delay doesn't get rid of the problem. You still have to make a choice. I have a def ref description of cyclic types with a hash table lookup in the middle, which Simple, by the way, lived with for a while. The earlier versions of Simple where I had structs immediately, they all had a def ref lookup. He lazily closed it. Like if he did the lookup, if he found the ref, he would do the lookup. Having found the lookup, he would replace in place to close the cycle, but it doesn't ever close them all. Because of the nature of the cycles. So you always end up with half open cycles floating around that you have to, so every possible place that you look through a pointer to get to a struct, you had to ask the question, are you a forward ref, basically? Are you an unclosed cycle? And if so, go back to the original hash table and close. That answer your question too, Arthur? This was like, what do you do with it? Well, you can sharpen.
Yeah, I can see. I am surprised that C2 has it, and I'll need to look if this part still survived and in what kind of form it is now.
Yeah, I remembered. I mean, I got to here because back in the C2 day, I realized I could almost completely unwind the missing generics, which meant that instances of linked list or array list, whatever, instances of your abstract generic type with erased types being used in a small domain where you had specific types, I would pick them up and know that I had a linked list of string or an array list of persons or whatever. I would recognize this and then optimize for it. You skip all the checks.
Do you need to see the allocation of these structures for this inference?
Something has to be handed into me where I get the base type. Like if I passed in an array list of object, then yeah, I don't know. It's full of objects. I'm done. If I've inlined from the allocation point to the use point, then I can start to see, oh, you're just passing in persons into this array.
Yeah, if you observe the allocation, it's easier, but most of the times you don't.
Well, there was a thing that you would get, which would be somebody would say, I pull a thing out and I cast it to a person. And then I have a fail that never failed. And so whatever, you have the off path. But then there comes around to, oh, so far it's only been Persians because everyone else would have failed. Then you kept adding Persians, and I would retain the knowledge of it's only had Persians. I'm trying to claim that that's true, and I'm not actually positive now. There was definitely scenarios where I could lift you to a Persian array from an array of object, and I'm trying to remember what they were. Like the new, I knew it was we were getting to.
Did you model the generic part in the type itself as well? Did you basically have it as the first class citizen, the generic
Not the
aspect?
generic, but the array, the backing array would get lifted.
Okay. Okay, I
In
see. Yeah.
fact, this is one that I know I did. I would look and see that you were testing this array, doing array store checks for some person-y thing, and I didn't know that you were to test the whole array or not. But in this area, you were checking for person-y things, and you never failed so far. So a heroic optimization, I would lift the whole array to be full of persons. Not be a person array, but the array of object was full of persons. I would list that in the type system, and then if that turned out to be false, I would have to unwind and rebuild and whatever. You have to rejit.
Mhm.
But if otherwise, I would start by saying, okay, we know I'm only going to get persons out of here. What do we do with that? I think I tried to cast you to an array of persons, but array list doesn't actually do that. Array list leaves you as
With arrays, it's more straightforward. With arrays, I don't think you have the cyclic aspect actually. It's just type of the array.
right. No. The cycle came around because you had linked list of, and there I needed all the allocations in place. I had a linked list of a thing, and I loaded the payload. I
But
loaded a
but then
generic
you
payload with a string, and then I had a loop where I loaded generic payloads with only strings. And then I came out with a linked list thing whose generic payload had only been loaded with strings. And I could tell that because it didn't mix with any other linked list.
but then you need to somehow model the type of the payload. That's where my question
Yeah.
about
That was
model the generic.
the C2 would say I have a struct type who has two fields annexed in the payload, and that payload was known to be string. It's not the type definition as written from the original spec. It's the types as inferred by the optimizer during looking at analysis. It's the same.
Oh, okay,
You
so
run the
you infer the structure as well, not just the type of the pointer only.
you have to be careful there. Right. It's nice to say that, but it's actually I'm told the structure type. The structure has two fields, so I'm not inferring that structure, but I am inferring that one of the fields, the payload field, got lifts from object to string.
Okay.
In AA, I'm doing type inference on the whole struct, yes, but not in C2. No, I was handed.
Mhm.
So, I mean, maybe we're missing terms on what it means to be inferring the structure. I'm inferring individual fields.
But the, but anyway, in the code, this field is just another load, and you're basically inferring the type for that load.
Yeah. I'm
Um,
inferring the type for the struct, which means that loads will then infer that they load a string. But I have a memory representation of a linked list object that has its own closed cycle.
okay, I see. So that's the yeah, for us in Falcon, we look at these loads just independently, and yeah, we consult with the VM layout of the object. So we get this part of the spec, but we don't do this kind of inference where one depends on another because we see it in one context.
Yeah, okay. This was okay. This was me saying, I got a loop, and then came a null, and then I said, man, new linked list, shove a string in, loop it around, the pointer that I'm carrying in the loop is now typed as either null or pointer to linked list with a string. And then you run through and you add another string and you get the same type and you close really, really quickly and you now have inferred as a linked list of just strings.
Mhm.
I'm you would have to go look. I don't want to steer you wrong. I know I saw cycles in C2 and I had to deal with it in the hash table interning. So that was there. I'm pretty certain what I just described to you, I was also doing. Um, but I had to not have it mixed with other unknown things. So you handed me a linked list. I didn't know what was in it, and you added a bunch of strings on the end. I didn't do it. All right. What other fun things to do here? So I claim I've got this now working in simple without actually having a whole lot of tests or anything. So who knows? But it passes all the. It's a lattice. It will run to completion. It will give me a
Haven't
fixed point
seen
solution.
haven't seen York in a while, so maybe we can get an update from him.
He's trying to find a job. I say, go consult. He's like, I don't like consultants. I don't want to be one.
I mean, I've continued working on Inko. Let me see. The big thing uh, it's a typical yak shaving. I started working on a HTTP 1.1 stack, uh, specifically starting with a server library and then client afterwards. And then planning also to do HTTP 2 and probably going to skip HTTP 3 because it also needs support for Quick, which, yeah, it's essentially the whole new protocol layer. And given that it's quite rarely used, I figure, that can probably wait. Um, Then, as part of that, I did some refactoring with Inko's IO types, specifically the interfaces it uses for reading and writing.
Mhm.
The model it uses there is kind of similar to Rust in that you have a write interface and it has a write function that it requires and some other stuff. And you can implement that for like files, sockets, whatever. And in the Rust model, the return type of that function, write, is annotated as it's a result. And it either returns the number of bytes that it wrote, or read, in case you do read, or it returns an IO error type. And that error type is a concrete type like a struct, not an interface. But then these problems you can run into is if you write some sort of wrapper like a reader that takes as input some other read type, and then it gzip decompresses it, for example. And what you would like to do is implement it in such a way that if you say, oh, I just want to read from a file, you can give it a file, or you can give it a gzip reader that wraps a file or some stack of things. And this is useful in HTTP because HTTP can send you its response directly. It can send chunked responses, but it can also send responses that are gzipped on top of chunked, although that case is, I think, quite rare. But basically, you can sort of stack different formats on top of each other. And you don't want to tell people like, oh, if you use a gzip response, you have to use this type, and otherwise that type. No, they should be transparent. But you run into this issue there if everything has to, like if the error type is converging on this generic error type, then in case of Rust essentially represents the error number global variable from C.
Yeah.
You don't have the ability to produce custom errors. Like you have to sort of constrain everything to like, oh, is this does it fit into one of these existing error codes essentially? Rust has this model where they sort of acknowledge that. So you have all these different cases like, oh, file not found, file is directory, etc. And there's this magical one called other. And you can basically stick an opaque pointer in there and then use effectively runtime typecasting to turn that into a concrete type. The way it implements it does like at runtime, it maintains some type ID information that it checks at runtime. So there is a bit of a cost. It's not too bad, but the core issue is basically you define an error type and you have to design it so that other people can stick their data into it without making it generic. Because that means now every time you have an error type, you have to say, hey, what is the type of that other case, even if it never occurs? So the first yak I shaved there was that I tore that model apart and made my read and write interface on such generic over not just their input or what they produce, but also the error type. So read, for example, used to be just interface read, and its read function returns result number of bytes or an IO error. Now it's read over some type E, and that's the error type. And then similar with write, etc. But that triggers a sort of cascade of changes where everything that depends on that has to also change. So I got that working, pushed it, worked, merged it, and then CI was like, oh, there's an error where when we try to link objects, they're duplicate symbol names. In other words, effectively different types are given the same name. And I put the check in place a while back because I had this case where due to some bug in the incremental compilation implementation, it would sometimes produce symbols with duplicate names. And then you get a linker error. And that was due because some ordering issues, it wasn't using certain caches properly and whatever. And that check now popped up again, like, hey, duplicate symbol error. And initially I thought I'll just ignore that for now, power through, and we'll fix that later. And I'll restart the failed tests. But they keep failing. And I try to see are there any quick workarounds, but no, there's a problem. And the problem, as far as I understand it, is that the way types are currently specialized in the compiler has at least historically been the source of this problem, where depending on the ordering, it produces a different output, and that then kind of messes up with incremental compilation, etc. And I had some other issues with my specialization setup in the past as well. And so I now decide, you know what? I'm going to rip it out. I'm going to do different, which is yak number 2. The old model basically, rather than specializing, say, each generic function or type over all the like individual types used with it, like the traditional monomorphization or specialization approach, I grouped certain types together. So the idea was, if you have a value and that's just a pointer to some structure, it's in a way kind of stupid if you generate 5 different functions that happen to use that thing, if they all happen to use it in exactly the same way, because it's a pointer. So in other words, like if the instructions are the same, it's kind of redundant. And then there was the optimization where like, oh, if the type is stack allocated, then we do specialize individually, because you need to know the size of that thing in the stack. And so essentially it was the traditional specialization, but by default types all grouped together into this one thing, which I refer to as shapes. Very creative. But this has led to a bunch of problems because you have these different types. You need to sort of converge them into one entity. That in turn, at least in my implementation, results in a lot of complexity, especially surrounding dynamic dispatch. And the way I implemented as part of the specialization, you had to perform certain like sub-type checks to see like as part of dynamic dispatch, like, hey, can we actually specialize this function? Explaining exactly how it works is probably 2 hours of material, but in a nutshell, it It's complex, quite buggy, and I really hated working with it every time I had to touch it because I sort of knew like, oh, okay, any change I make here, that's 3 weeks of my life gone. Um, and then from the perspective of compile times, so one of the benefit of grouping is you have less code that you generate. And so in theory, there's less code that say LLVM has to chew through, which means in theory you get faster compile times. Um, but I was never fully convinced that this grouping is the solution to that problem. In exchange, I had noticed, for example, writing this HTTP stack and other things, that there's a fairly clear difference in performance when I use types that I knew are can be specialized individually versus those that are specialized as a group and thus use dynamic dispatch for function calls. So the case I ran into, for example, is strings were specialized separately because they use atomic reference counting, whereas normal values use regular reference counting. So you need to separate the two. And so what I noticed, for example, when writing parsers that take strings as input, they would consistently perform better compared to when they take a byte array as input, which is specialized through dynamic dispatch. Now the difference is not like super significant, but it's, oh, a parser over a string takes, let's say, 100 nanoseconds, and a parser over a byte array takes 150 nanoseconds, which in isolation is not important, right? 50 nanoseconds, woo. But that stacks up, like that difference exists everywhere, basically. So if you look at the compile times versus the performance cost, I'm not convinced it's worth it. And in theory, also by specializing over individual types, now, for example, inlining can be done more aggressively, which means theoretically other optimizations apply more, which can actually reduce the amount of code. Um, and yeah, so the
Yeah,
result is like,
that'd be an interesting thing to look at. Like, what's the actual from your own corpus of work? What's the actual impact? Because you would think with more specialization, you'd end up with a giant C++ wads, right?
right.
The
And so that's
the
where
explosion.
what my compiler already did, because it's a whole program compiler.
Mhm.
What do we do after specialization? Would essentially traverse the call graph, throw away methods that it figured are definitely not called.
Hmm.
The thing was that was quite pessimistic because what happens when it encounters a dynamic dispatch call site, which in this case would also be used for generics, so you'll find quite a lot of those. It has to pessimistically assume that any type that could end up there might get called. So if you have a call site where it's it calls a two-string method on some generic thing. If you have 100 types that happen to implement the two-string interface, it will basically have to specialize all 100 of them. And then
Oh,
because they
wow.
might be called, it can also not remove them because of how things might be cast. It doesn't have that information.
Hmm.
And so the result is that in theory, grouping can reduce the amount of code you produce. But because of that pessimistic nature, I suspect the worst case might actually be worse than specializing separately. I have no data to back this up. I won't know until this works. I wouldn't be surprised if I'm
Right.
partially wrong. But at least the current, more traditional implementation that I'm working towards is a lot more straightforward to wrap your head around.
Hmm.
There's still some tricky things with dynamic dispatch where if I cast uh, if you like cast types to interfaces and then call them later, um, yeah, basically there's some ordering issues where you might have to redo some work based on the ordering. Again, I think too much for the time left. But basically, my conclusion so far is the more traditional implementation is simpler. Performance-wise, again, theoretically, is probably going to offer more benefits. Code size and compile times wise, I think it really depends on how you implement your compiler as a whole. and the sort of tail of optimizations that comes afterwards. And in terms of simplicity, definitely a lot better. So that's basically what I've been working on the last, I don't know, 2, 3 weeks. Then hopefully once that works, hope that my symbol errors are gone, and if it's something else, I'll probably have another yak to shave there.
Yeah. I'm hoping my typing errors are gone now. I can go back to implementing something interesting. All right. Oh, here's Matt going into chat.
So Haskell compiler has done something similar in the two stages. The levity polymorphism and kinds are called conventions. It's basically the idea if you have parametric polymorphism, you don't necessarily want to instantiate the types every single type. In particular, the types that have the same representation in memory can be made to be coercible. So if you have something that has two 32-bit values, maybe one is uint32, the other one is int32, but you may still allow to not generate, not stamp out those instances or have coercions between them. And they kind of worked it out, tracking this basically as kinds, because in Haskell, types also are allowed to have kinds. It's also used for user-defined types like for FFI, like if you want to interoperate with C and you want to pass something that's going to match a bit field, which has such and such particular value at particular bit. Haskell doesn't support those types in the normal language, but you can actually define types like this using hash. And you can also interchange them. So they kind of did some work on this.
I'm sorry, you can implement them using what?
The lower level Haskell, right?
Oh,
The Haskell inside the Haskell. I assume that's what he meant.
Yeah, so the model I currently still use, but I'm moving away from, is very much based on at least my loose understanding of these Haskell papers and experiences. Like I think the levity polymorphism, particularly if I remember correctly, that's essentially what I'm doing with shapes,
hmm.
where I say like, oh, I have a shape for integers, for floats, strings. Uh, I have a few for like the different kinds of borrows in my language. Because borrows use reference counting, for example. And then there's this sort of catch-all bucket for owned values that are heap allocated. So it's yeah, the model is based on what I understood from it.
Sounds similar, yeah. By the way, quick answer to Cliff, these are called unboxed types. You introduce them using hash sign. It's called magic hash.
Oh, I see.
Because you
Okay.
have like integer, normally it would be boxed, because there is this assumption of uniform representation when it really would be a pointer, but you can also have unboxed, like think of value types, where you
Right.
literally have the value, and that's spelled int hash as opposed to int.
And then the implementation, I guess, specializes cogen for the different versions,
But only when necessary.
but only when necessary. I
They,
see.
there is this polymorphism between the same representation
Right.
or in memory can still use the same
The
specialization.
wad of 32 bits, you're just moving it around. It can don't care if it's a pointer or a float or an int. Yeah. Okay.
Yeah, so that's basically the model that I was using, and the one I'm moving to is basically the traditional specialize all the things approach.
I'm busy looking at GHC unboxed primitives here, which gets into the whole, right. Yes, it is a design call I did with simple saying the primitives are like Java, they're primitives, and they're not going to get boxed.
So what's interesting, you can do this for anything, even user-defined type. So if you have like a maybe monad of int, you can have maybe hash of int, you can have maybe hash of int hash, you can have maybe of int hash. So you can actually choose what you unbox as a programmer in Haskell.
Hmm. But you
Hmm.
still end up with the some specialization is happening, but it can be unified based on size as a memory representation. And then somewhere along the way, when you want to actually do something with the thing, somebody has to do an instance of test that says it's an int or a float, or the typing system knows somewhere along the way. You unboxed a WAD and you had shared versions of the unboxed thing. Like the obvious thing is I have an array of a collection of them. And I want to say this array has a collection of ints. And that array is a collection of float 32s, and they're all 32 bits. So we do one implementation that takes an array of 32-bit things. And I have this pile of them. So I have a bunch of these arrays floating around. They have either ints or floats. Then I want to go use them, and I want to be type safe about using them. Somebody has to say, even though the code that implements the collection and allows you to add and increment and doubles the array and does the length thing and tracks length and overflow and whatever, that's the same for them both. The consumers know that they're getting an int out or a float out.
Right.
So I'm
One
asking, this is the obvious implementation or
one combination is disallowed actually, something like maybe of hash int. That's disallowed.
maybe because
But you can have maybe hash of
right
int hash.
where maybe would otherwise be represented as like a null pointer.
Because you would be assuming that it would be a bot's type otherwise.
Right. Right. Yeah. Yeah.
Okay.
Sounds like fun.
Yeah. H2O kept a separate. It's you're a not, you're a maybe, you're a not available. Separate, not available, which I guess is the maybe thing, independently for each different kind of base array thing that's going on, so that I could sidestep a otherwise valid value. I knew that you didn't ever use 1, 2, 3, 4, 5 in this chunk of code, so that was the magic token that said you were not available. It was lossless and also not available, which would use all your bits if you didn't have some shortcut or whatever, you did some trick to get around that. All right, what else? Or we can just be done. I have no problems calling it. I have unrelated all kinds of things going on today. I'm finally buying a mountain truck. So my sports car quits bottoming out when I go try to carry things, 4x8 sheets of plywood up and down the mountain.
Is it a convertible?
No. We actually borrowed a neighbor for the 4x8 sheet. We borrowed a neighbor for the several pieces of 4x1, 1x4s and 4x4s. We use Lisa's hatch with the trunk open. In the past, when I've taken big pole-like things, I would just stick out the side, all windows down, have it stick out the side diagonally. Um, but this
I was
happens
just
more
asking
often around
because
here.
I've always been amazed how much I can get in a convertible. You know, it's like, I'm gonna go get some lumber. What are you gonna
Right.
take? Oh, the
Well,
convertible.
there you go. Yes, that's what a pickup truck will let you do. Stack shit
I
up
don't
and
have a
out the
pickup.
back. So other things I bought. I finally figured out how to tame my lawn when it's spring. It's done now, but it has this 2 months where it grows stupid crazy and then it all dies in the dry season, and it's a massive fire hazard. So you have to mow it flat, and it will grow to 5 feet tall. But a three-dimensional foamy marshmallow of dried foxtail and other things that will just flash burn like madness. So you have to cut it down. And I went and bought a high-end professional grade weed whacker. It's got the big motor. You know, everyone says, "Oh, you can't have little two-engine stroke things in California, pollution, blah blah." There's this shit you cannot get away with a battery. Battery has no chance against the amount of crap going around here. So, yeah, two-stroke motor, high end. It's got a metal cutting blade. It's a beast. I can wade in, and it's like using a scythe. I'm on a 35-degree slope, and I got shit that's up to here, well, easily at my chest, but often up to here. And I swing this thing like a scythe through, and it just mows shit flat, and it catches and carries, and things would just chews up the battery. My battery guy chokes on and winds around the cord and doesn't cut or whatever. This guy just cuts it through, and you just like sweeping through a field.
Just be careful.
Yes, I needed a bigger tool. I got a bigger tool.
Yeah. No, I
Well,
used to
yeah, so I
use
certainly wear heavy duty shoes and you take your precautions about falling over while you've got this beast running, but
exactly.
it will
That's
chop through everything. All good. This is my fun tool of the day. All right, done. Um, yeah, it's good talking to people. And maybe next week I'll show off strings and simple. That would be fun if that were possible.
yeah, I got a
Uh,
lot. I have a lot to show, but I think
oh,
I'll wait until it's all working. So
that might be a long time, sir. I show
no, it's
shit that's not yet working because otherwise I don't want to wait that long.
yeah. No, I understand. No, it's all so it's the framework for being able to unload class loaders and stuff like that
Ah,
for the Java backend. So
right. Yes.
yeah, so
I didn't get to that part and I knew it
that's
was
what I'm working on. So
wow. Okay. Well, good luck. And actually, show me when you got it. Show us when you got it. I'd be happy to see. This is like a madness thing to manage class loaders.
yeah, well, it's because one of our goals is super high density, so we don't ever want to load the same module twice, right?
Right.
So which means you have to separate it's graph theory, right? Like if you have a bunch of modules, you want to separate all the ones out that don't have dependencies because by separating them, you can now reuse them individually. You can share them into new
Yeah. Right.
class loading domains, if you will.
Yeah.
So it's all about plus we've got, conditional dependencies, and you have the equivalent of pound defines, right? The ability to have conditional code and conditional logic and different versions of the same module. So it's like I can reuse, but I can only reuse if it's the perfect match for what I'm looking for. So it's
Yeah.
yeah, a lot of details.
I got some of the conditional include things working, but
Well,
it
this
didn't give me
is
class unloaders, that's for sure.
well, so we don't have right. You're probably thinking conditional incorporates on the classes. Yes, you did on that. This is about conditional module dependencies.
Okay. All right.
So the
And you are
example,
doing, go ahead. Go ahead.
sorry, Matt, go ahead.
I was just curious if you are doing basically something like shared libraries in Linux doing deduplication, well, or any dynamic loader doing deduplication,
It's basically deduplication, but at a module level.
right? Because it's kind of scary because it turned out to be a whole bugs galore from the security standpoint. There is
Oh,
so many
yes.
things that can go wrong.
Yes. Well, keep in mind our type systems are immutable, which definitely helps that. But you could still have things like singletons or so within a type system, if I have a singleton type, it could be a singleton service, which could be stateful. So things that you might do in Java just by throwing a static onto a class. So for those of you that don't use Java, static is just
The
a
namespace.
shared. It's a field that's on the class instead of on the object, right? So it's a field on the type instead of the object. So we can't do that same trick because then it would bleed across type systems. So that has to go onto the container, not onto the type.
Yeah, I would say
Anyway,
you can do the same trick, but you don't put it on the type.
exactly.
It's
Yeah,
it's in a global space somewhere, but it's not actually global anymore in your case. It's
correct.
local to the container. Yeah.
Yes.
Yeah, C2. Hot H2O hit an equivalent operation where a static would be true on one node, but every node had its own copy of the static.
Yep.
So we had rules about how to use statics and when they were appropriate. We didn't enforce any of the rules. You could break yourself, but
Yep.
there was a stylistic rule that said, here's when it's appropriate.
Yeah, we've definitely encountered people hitting tripping on that wire in
Yeah.
clusters where they're
Yeah.
like,
Yeah.
yeah, I can.
Yeah.
Yeah.
For me, the rule is actually pretty easy. It was read only, or you had to use a reducer to look at it, which did a reduction across the cluster and gave you the approximated, well, not the approximated, the reduced version. So it was very common to have shared statics you wanted to have, but they would have to be read-only unless you were intending to gather a singleton value. It had to run, it had to run through a reducer. And
So the main difference, by the way, since you wrote the what's the basis for this is you had just a single class loader for the system. So what we do is we have a type system class loader, which doesn't actually load classes. So it's just a delegating model, if you will. And then we have individual module class loaders. So each type system class loader is a collection of module class loaders. So it can direct traffic down to the module class loaders. The module class loader loads only the things that it's responsible for. So within its Java package, basically. So it does a string match on a Java package and sends everything else up to its type system class loader, which then might direct it down to a different module in the same type system, or, lets it go to a default Java route. And so so each type system has one class loader for itself, and then any number of module class loaders under it that it'll direct to. But some of those module class loaders may be shared, they may already exist, so it may grab them from another type system. So for example, the Ecstasy core libraries are loaded by the initial container, and those libraries get shared all the way down. So that way we only load the same code one time is the idea.
Right. But you
But yeah,
virtually think of it
it'll
as
be fun
having your
once
own
it's working.
private copy. All right,
And
this
as-
sounds like an in-depth discussion for another time.
Sounds good.
I'm going to call it bailout, but I'm happy to have you talk about module loaders, especially if you can show code. You actually
yeah,
have enough stuff working. You probably show stuff.
Yeah, I'm headed there quick.
Okay. Well, until we meet again,
Have a good one.
we'll see people next week.
Be careful with your weed whacker.
Oh yeah. My new tool, my new toy. All right, bye-bye.
Right.
Bye.